Assalamu alaikum and hello to everyone. Today we're going to talk about emerging data communication technologies, and the presentation we're presenting is on Starlink. And this presentation is presented by Alishbah and Faisal Shabbir. Now, first of all, we're going to talk about recent networking technologies. Let's not go into the future. What about the network availability around the globe? Although the internet has been one of the fastest growing technologies in human history, by the end of 2019, more than half of the world's population would still be offline. That's about 4 billion people. There are many areas in the world which are still deprived of network connectivity due to their location, just like the mountainous areas and villages far away from human contact, where there's no way to provide land connectivity and they cannot afford mobile data networks, which are really expensive to pay. Now, let's talk about the connectivity and speed. Let's talk about video streaming from the start. Video streaming day by day is a requirement. As you can see by online classes and many other things, and the quality of video streaming has been increasing, which requires more bandwidth and more speed day by day. And as you can see, high speed internet is not available in many countries, including many third world countries. And as you can see, there are many other reasons we need a lot of speed in networks. For example, some financial companies with millions of dollars being moved in fractions of seconds, having a lower latency would provide a massive advantage in capitalizing on price swings. So these financial companies require faster internet, and they're willing to invest in emerging technologies for faster network. Even though fiber optic is up to date, but we need faster than for our future. Now, what about the mediums we are already using, like the optic fiber we talked about? It's estimated that in the US alone, a 4G to a 5G conversion wireless connection will cost around 150 billion in fiber optic cabling alone over the 7 years. That's a huge price to pay. And let's see, do you think there are any solutions to these problems we have faced or we are facing due to space connectivity in our recent technology? That's where Starlink comes. And back in 2015, Elon Musk announced that SpaceX had begun working on a communication satellite network, stating that there's a significant unmet demand for low-cost global broadband capabilities. Around that time, SpaceX opened a new facility in Redmond, Washington to develop and manufacture these new communication satellites. Now we're going from this land communication to the space communication. On the 24th of May 2019, SpaceX launched a Falcon 9 rocket filled with 60 satellites into space. This marked the beginning of the ambitious new project Starlink, which aims to provide high quality broadband internet to the most isolated parts of the planet, which also provides low latency connectivity to already well connected cities. The initial plan was to launch two prototype satellites into orbit by 2016 and have the initial satellite constellation up and running by 2020. But the company struggled to develop a receiver that could be easily installed by the user for a low cost. This delayed the program, and initial prototype satellites weren't launched until 2018. After a successful launch of two prototypes, Tintin A and Tintin B, which allowed SpaceX to test and refine their satellite design, SpaceX kept pretty quiet about what was next for Starlink project. But until November 2018, when SpaceX received an approval from the FCC to deploy 7,500 satellites into the orbit on top of the 4,400 that were already approved by FCC. Now let's talk about the future. The launch of 60 satellites was just the first of many. SpaceX has 12,000 satellites planned for launch over the next decade to improve their constellation, which makes it easier for Starlink to have connectivity all over around the world and provide it to us. This will cost SpaceX billions of dollars, so they must have a good reason for doing so. SpaceX aim to make their broadband as accessible as possible, even for the third world countries, claiming that anyone will be able to connect their network if they just buy a pizza boxed antenna, which SpaceX is developing themselves. Now let's talk about how Starlink works. And in the satellite, the iron thrusters will initially be used to raise the Starlink satellites from the release orbits at 440 kilometer to orbital height of 50 kilometer. 440 kilometer to 550 kilometers. Sorry. The US government space debris collision prediction system to allow the satellites to adjust their orbits to dodge collisions. As there are many 12,000 satellites to be launched, there should be a system to avoid collisions between the satellites. When the satellites have reached the end of their service life, they can then use the same altitude controls and thrusters to deorbit the satellite. This was my part of the presentation, and the next part of the presentation would be presented by Alishbah. Thank you.
Okay, so let me first complete how Starlink works, and then I will give you an insight on how Starlink is going to change our lives in near future. The primary function of a satellite is to bring our communication abilities. The satellite will contain 5.15 kilogram of silicon carbide. That means 5 individual lasers for each satellite. The laser will use light pulses to transmit information between the satellites. Transmitting light in space offers one massive advantage. The speed of light, as we all know, that it's not constant in every material. In fact, light travels 47% slower in glass than in vacuum. This offers Starlink a huge advantage. This provides the potential of low latency and over the long distances. As we all know that the speed of light in glass depends upon refractive index, and index depends upon the wavelength. But we will take the reduction of 1.47 times slower than the speed of light in vacuum. What that means that if a data packet roughly takes 0.063 milliseconds to make a round trip and has a latency of 0.063 seconds or 62.7 milliseconds, with the additional step the whole time will make up to 76 milliseconds. That's a huge delay, and Starlink is going to reduce it. The next part of the Starlink is its antennas. Each individual Starlink satellite has four phased array antennas. As you can see in the diagram, the four silver metal plates are the antennas. Each satellite has a cone beam with 81-degree range of view. With an orbit of 550 kilometers, each satellite can cover a circular area with radius 550 kilometers. SpaceX originally planned orbit to cover the radius of 1060 kilometers. Lowering the altitude of the satellite decreases the area it can cover but also decreases the latency. The latency could be as low as 3.6 milliseconds if the Starlink is intending to operate at much lower altitude. By that, latency can be reduced. Now I'm going to talk about the constellation strategies of SpaceX. In the first phase, 1500 satellites will occupy 24 orbital planes with 66 satellites in plane and inclined at 53 degree to each other. The problem is how are they going to communicate between each other with the neighboring satellites? Communication between the neighboring satellites in the same orbital is relatively very simple, as these satellites will remain at a stable position and in relation to each other, so they are going to communicate in that way. The problem here is that it requires precise tracking. As the satellites traveling in the neighboring orbital and traveling incredibly quickly will come in and out of the view, and this can cause a serious problem. This means that Starlink will have to switch to new satellites in the network, and this is going to take a lot of time. Last night, when I was compiling this presentation, I noticed that, and I had to send some files, I noticed that the data transfer rate was very slow. And on the other hand, at the receiver end, the data transfer rate was not so slow. So I thought that what big of a blessing Starlink is in our lives. Okay, Starlink can be the fastest, but it's not instantaneous. And for this purpose, five optical communication systems are on board to maintain a steady connection of four satellites at all the time. Now, if we use the system and we transmit information from New York to London and back with the shortest path possible, using the speed of light in vacuum or transfer speed, we can achieve the latency of 43 milliseconds. Even if we take the shortest path possible, that is optical fiber these days, it will take 55 milliseconds, and that is 28% decrease in speed. The actual current trip, that is from New York to London and then from London to New York back, is going to take 76 milliseconds, and that is 77% decrease in the speed. Now you see how Starlink, it can reduce the latency rate up to 77% or 28%. That's a huge difference. Let's just talk about the connectivity issues now. We all know that the people living in villages, people living in mountainous regions, or people living far away from the cities, they how difficult it is to connect to the internet and how deprived they are of the basic internet facilities. SpaceX, on the other hand, is planning to provide super fast internet to them. The plan of the SpaceX or Starlink is to connect every human to the internet. We know that there are regions where there is no land connectivity, and even if there is a connectivity, Starlink is going to provide them faster and better internet and high speed internet. We all know that internet is the basic fastest growing technology of the human history, but sadly there was a survey that was taken in 2019 and it showed that half of the world population is still offline. How alarming that is. Now, there's going to be a very interesting question in everyone's mind that if Starlink is aiming to provide us all these facilities, it will, and it is going to ask us for a lot of money. But let me remind you that users will connect to this internet using Starlink terminal, which will cost only $200 each. This will still be far outside the purchasing power of many third world citizens. But it's a start and vastly cheaper and than similar currently available receivers. This will allow the Starlink to compete with traditional internet providers such as optical fiber in Pakistan and PTCL and whatever. It's estimated that moving the US from 4G to 5G wireless connection will cost around 150 billions of fiber optic cable alone over the next 7 years. But SpaceX is aiming to complete the entire Starlink project for as little as $10 billion. Each Starlink satellite cost around $300,000, which is already a massive cut in the cost of communication satellites. I would summarize my presentation by saying that, in short, all the problems we have discussed so far in the data communication technologies nowadays has opened a way for Starlink technology to shine in the future, as it is the perfect replacement for the best of the technologies provided to the humankind nowadays. It is even better in terms of providing internet facilities to the rural and difficult areas and to the areas all around the globe for us.